Hello and welcome. Today's session we are covering what's called classes and object-oriented programming. So we'll cover classes and objects. So this section or this presentation is very important in high-level programming languages. And the concepts that we go over here would be the same for other languages as well. So we'll discuss procedural and object-oriented programming. We'll discuss classes, working with instances, techniques for designing classes. Procedural programming, this is writing programs made of functions that perform specific tasks. Procedures typically operate on data items that are separate from the procedures, and data items commonly pass from one procedure to another. The focus is to create procedures that operate on the program's data. And object-oriented programming focused on creating objects. Objects, entity that contains data and procedures. Data is known as data attributes, and procedures are known as methods. Methods perform operations on the data attributes. Encapsulation, combining data and code into a single object. All right. There's a lot of information here, but it's kind of summarized in this slide. With object-oriented programming, it uses what's called objects. And what are objects? Think of prototype. When we discuss classes, objects, and so forth, think about what's called prototypes or a model or a design. So let's say you're trying to build apartments, okay? So you're trying to build apartments. The first thing you would do is you would create a prototype. You draw the prototype or the design and say, or a blueprint is another name used, and say this is the design I want to use for the developers that are building these houses or these apartments. So with this design, you basically show the room would have 2 windows or 1 window, the doors, the type of lighting you would have in the house, the setup of the kitchen, the bathrooms. All this, you put it in the first prototype or the first blueprint that you create. And then from there on, you would create another objects from that. Like, for example, if you take this prototype, you take it to China or you take it to South Africa, you take it to Asia, any developer, you would give it, and then you would say, this is how I want these apartments to look. So any developer should be able to mimic the prototype or the design that existed. This is with the object-oriented program, with the objects, right? So these objects have what's called, attribute and methods. Another name is it has what's called a state and a behavior, okay? These objects have what? A state and a behavior. The state would be things that come with it basically by default. All right. If it was an animal, let's say the object was an animal that we were creating, the state would be what? What are the things that come with it? Animal would have what? Legs, fur, ears, eyes, tail, and so forth. This would be the state. Another name for it is data attribute or just data. Does that make sense? Or just attribute. Attribute is another one, right? And then it would have a behavior. The behavior would be what's called methods. What do you do with that state? What do you do with that entity that you have? What do you do with that hand? What do you do with that tail? That would be what? The behavior, okay? So every object have what? A state and a behavior. Another name is data attribute or method. Does that make sense? Then encapsulation is combining data and code into a single object. Kind of like what's called data hiding. You encapsulate, like the word says, encapsulate everything in one place. Okay. So here you have the object, you have data attribute, and then you have the methods. So this would be like the legs, the hands, the ears, the eyes. This is, and then the state, that's the state, and this would be the behavior. What do you do with that hand? The hand to go up and down, the leg to move left and right, and whatever it might be, right? The tail to wag and so forth. Okay. Data hiding is objects' data attributes are hidden from the code outside the object. Access restricted to the object's methods, protect from accidental corruption. Outside code doesn't need to know internal structure of the object. Object reusability, so the same object can be used in different programs. Example, a 3D image object can be used for architecture and game programming. Okay. So this would be the code outside, doesn't need to know the details. Data attribute would be the defined state of an object. So an example, the clock object would have a second, a minute, an hour, and a date attribute. Public method allow external code to manipulate the object. Example, set time, set alarm, set alarm time. Private methods used for objects' inner workings. Classes, code that specifies the data attribute and methods of a particular type of an object. So it's a code that specifies. So you have the class, and then within that class, you would state the data attribute or the state, and then the behavior, the methods. Okay. Similar to a blueprint or of a house or a cookie cutter, an instance in an object created from a class, meaning that if you created that prototype, so when you take that prototype to Asia or Africa, anywhere, you're just saying basically, let me create another object from that. Any other house that you create, apartment you create from that, should be of the same format. Similar to a specific house built according to the blueprint or a specific cookie cutter, there can be many instances of one class. So this is a blueprint and a house built from a blueprint. So you have the blueprint and then the instances that I created from. Same thing with the cookie cutter. Okay, so here you have a class called insect, and then these are other instances or objects that I created from the class. Class definition is a set of statements that define a class's method and data attributes. Format is begin with a class and then class name. Class name often start with an uppercase letter. Method definitions like any other Python function. Definition self parameter required in every method in the class references. The specific object that the method is working on. Again, with the self, you can call it self or you can call it whatever else you want, okay? But it's required. Initializer method automatically executed when an instance of the class is created. So initialize this object's data attribute and assign the self parameter to the object that was just created. So the format will be defined, and then the two underscores, then init, and then self. Usually the first method in a class definition. Actions caused by the coin expression. Here you have the coin object, and then the coins class init method is called, and then self parameter is set to newly created object. Okay, so this you would use whatever you pass here, and then side up is called heads. Maybe we'll use an example like that. After these steps take place, a coin object will exist with its side up attribute to set to heads. Okay, to create a new instance of a class, call to initialize method. So format would be my instance, and then it would be class name. To call any of the class methods using the created instance, you use the dot notation. So format would be my instance dot method. Because the self parameter references the specific instance of the object, the method will affect this instance. So reference to self is passed automatically. An object's data attribute should be private. So to make sure that of this, place two underscores in front of the attribute. So it would be like that. Classes can be stored in modules, so file name should end with .py. In your assignments, if you look at on top of the lab requirements, you're supposed to submit your assignments using the rebel.it. You just submit the link from there, okay? Rather than submitting a file. Module can be imported to programs that use the class. So class methods can have multiple parameters in addition to self. Maybe we'll use like one example like this. So for any parameters needed to create an instance of the class, so an example will be bank account object is created with a balance. When called, the initializer method receives a value to be assigned to the balance attribute. For other methods, parameters needed to perform required task. So example will be deposit method amount to be deposited. You have the str method, so object state the value of the object's attribute at a given moment. So the str method displays the object state. Automatically called when the object is passed as an argument to the print function. Automatically called when the object is passed as an argument to the str function. Working with instances. So instance with attribute belongs to a specific instance of a class. So created when a method uses the self parameter to create an attribute. So if many instances of a class are created, each would have its own set of attributes. Okay, so here you have the coin object, and then each time a coin is flipped. Okay. Typically, all of the class's data attributes are private and provide methods to access and change them. When we say data attributes, we are talking about the state, things that come with it, right? And the methods are the behavior. What do you do with that data attribute? Access the methods, return a value from the class's attribute without changing it. So safe way for code outside of the class to retrieve the value of the attribute. The mutator methods stores or change the value of a data attribute. Methods and functions often need to accept objects as arguments. When you pass an object as an argument, you're actually passing a reference to the object. So the receiving method or a function has access to the actual object, so methods of the object can be called within the receiving function or method, and data attributes may be changed using mutator methods. And you have what's called a UML diagram, so a standard diagram for graphically depicting object-oriented systems. You would do it when you get to Java. Stands for Unified Modeling Language. So general layout, the box is divided into 3 sections. So basically, top section is the name of the class, and then the middle section is the list of data attributes or the state things that come with it by default, like we said, the legs and the head and so forth. And then the bottom section is the list of class methods, meaning the behavior. What do you do with that leg? What do you do with that tail and so forth? Okay, so this is normally how it's written. Coin, and then side up, and then the init function, and then the methods here, right? When developing object-oriented program, first goal is to identify classes. Typically involves in identifying the real-world objects that are in the problem. What are you really trying to solve? That would be the top level. You can have a class called animal. You can have a class called a human being or a person. You can have a class called automobile. Okay, every other object will be inheriting from that top parent. Does that make sense? So you have to understand the top level. Okay, technique for identifying classes: get written description of the problem domain. Identify all nouns in the description, each of which is a potential class. Refine the list to include only classes that are relevant to the problem. Again, your last project 7 requires you to create just to make everything a class. Okay, you already have a working project of 5. You're just taking 5 and then just making a class. 6 is totally different from all the other stuff that you have been doing. Okay, and then once you create that class, that's basically it. Maybe you may add a few lines there to that project. Get a written description of the problem domain, may be written by you or by an expert, should include any or all the following: the physical object simulated by a program, the role played by a person, the result of business event, record-keeping items. Identify all nouns in the description, each of which is a potential class, should include noun phrases and pronouns. Some nouns may appear twice. You refine the list to include any classes that are relevant to the problem, so remove nouns that mean the same thing. Remove nouns that represent items that the program does not need to be concerned with. Remove nouns that represent objects, not classes. Remove nouns that represent simple values that can be assigned to a variable. So a class's responsibility are the things that the class is responsible for knowing. Identifying these helps identify the class's data attributes. So you have an understanding of the general stuff, very important. The actions the class is responsible for doing. So this identifying these helps identify the class's methods. Basically, what do you do with that leg? Once you say, yeah, the animal should have legs, tails, and then you need to know what do you do with that, right? To find out the class's responsibilities, look at the problem domain. So deduce required information and actions. So let's look at an example of doing this. So first, let's create a class and call it food truck. So this class, and then we'll define and we pass the parameters, right? We had a quick one earlier. Yeah, I'm writing food menu to make sense for you, but the presentation says we call it self, which is a mandatory, but you have a choice, whichever one, whatever you want to call it. Okay. So this is a must for the init that you have to have. Let's say chicken, rice, whatever you're selling, right? And of course, you list all the variables that you have to declare there. And then we prefer, you can say self again, you have a choice there. And we'll say food menu dot chicken equals chicken. Food menu dot rice, rice. And then we can create another function that we want to pass, and then call it maybe output function. Okay. And this would be maybe our receipt. And then here, since this is the output, we can say print chicken receipt dot chicken. It should be rice. In your case, it will be whatever items that you're selling, and then however many, right? So here we'll just say food equals call the function food truck. Now here we can pass, let's say we are selling the chicken $2.99 and maybe the rice $1.99. Now we have to reference this and then say food that what do we call output function. Let's run this. Output. So you have it. Chicken is $2.99. Rice is so basically $1.99, right? So we declared the function, called it food truck, and then the init is a must you have to have, and then here is the self parameter. You can pass as many other parameters here. This is normally what's called self that we were discussing, but you name it something that makes sense. So that is the one you will reference using the dot to define, to reassign it. Now here you have another function that will do the output for you. Again, you will list whatever you're outputting, and then you will say food equals food truck, and then the cost of each, you pass it, and then you say food the output function. You're calling this function so that you would have this printed. Okay. Of course, you need this because the previous project, project 5, requires you have many functions. That's you. You have to create your other functions as well, right? So define, let's say, header, right? And then your header would be whatever the restaurant name is, right? The chicken place or something like that. Right? Of course, the header has to be there. Then 555, Largo Avenue, /n. You know what the /n is by now, right? And then Maryland. /n. Telephone 555. And of course, you can format it and make it clean however you want. Now with this print, what we need?
We need to call it.
We need to call it. Okay, and since it's a receipt, we want to put it in the header. So here you can just say header. And then he would show the address, check and place the address, and then, of course, here I'm just showing you the basics. We have done a detailed example when we covered function. And instead of the price here, you can create this, but you have to create another function that asks a question. You can pass it as parameter, where you set one function that just lists this, and another one that passes two variables. And then for the calculation, you create another function that multiplies those. I think some of you have done that already for those of you that submitted. Either option is fine. Okay. The only other thing that I need to remind you, which I shouldn't at this point, is documentation. Make sure you document all your work. Your name, when the project was written, the date, the time, each function you create, what it does. If you're introducing a new variable, make sure what that variable is holding and so forth. All right.